Morning, folks. Welcome to Just Talking 24, page 57. This morning, we're going to be a geek squad. The subject that I'm going to be talking about is not a subject that you talk about every day. And it's not a subject that you might even talk about in your life. But it's something that bothers me. And it's bothered me for decades. And that is science. I'm interested in science. I'm very interested in science. Science explains how everything works, right? I mean, almost everything. But there's so many inconsistencies in what my teachers would say and what experts, and I'm putting experts in quotes, experts say. And one of them is about gravity. Okay, I don't say that gravity doesn't exist. It exists. It's real. Okay, but it's it's like a catch-all for everything. These astrophysicists. They say that gravity is what keeps the moon to the Earth, and gravity is what keeps the planets in rotation around the sun, and you know, they give a lot of importance and a lot of property to gravity. And I don't see gravity as being all that powerful. Really, it's a force like anything else. Like the sun's energy, it warms up the Earth, right? But yet it doesn't warm up Jupiter. It won't warm up Saturn. It won't warm up Uranus. It doesn't reach that far. See, everything physical. Okay, and I was taught this also. See, this is the part about science. They tell you everything physical has a limit, yet certain things have no limits. And one of the things is gravity. Um, I've asked many sources, at what point does the gravity from Earth stop? Where you go, total weightless. And, these astrophysicists say, well, you never now, not a long time, you never escape Earth's gravity. You always have gravity. And I said, wait, then how do the rockets go to the moon without constant propulsion? They reach a certain point and then they just coast all the way to the moon, 230,000 miles away, if there's gravity. They have mass, they haven't lost any of their mass, they haven't lost any of the weight, and yet they keep moving away from the Earth because another law comes in. The law that an object will remain in motion you know, unless affected by another force equal or greater than that object is, whatever. And so at some point our gravity stops, right? Okay, so um, even the space station is 225 miles up from the Earth, and they said, oh no, but the Earth's gravity still holds it. It's just that we're actually free falling, you know. And it's no, at some point, gravity has to stop. Okay, and my way is real easy. You just put a plate, put a scale, put a 20-pound weight or put a 100-pound weight, and when that scale measures zero, that's the point in which there's no gravity, because that's how we measure gravity on Earth. It's and the weight that the word weight is just a mass. Yeah, it's you get a cubic foot of lead and you get a cubic foot of feathers. Put them on a scale, and that's the difference of mass, which we equate to the difference of weight. Okay, so all you do is get 100-pound weight at sea level on surface, and you just take it up until that scale goes to zero, and you can go as accurate at a scale as you want. But at some point, that sucker will almost go to zero, and by then just holding it to the scale, just holding the scale down is gonna be hard because that sucker will be floating around too. But one if what I'm saying is true, then our tides on this earth, they're said, they say that the tides are caused by the moon. Well, they're not, folks. If what I'm saying makes sense and is true, the tides are caused by the earth. And there's a real simple reason to that. How can it be caused by an object that has 1/6 the gravity of Earth? Think about it. Say the Earth's gravity stops pulling at, say, 50,000 miles. Or say 60,000, because 60,000 easier for me to divide, okay? So it's 60,000. If the moon has 1/6 the Earth's gravity pull, then Earth 60, moon 10, because 1/6 of 60 is 10, right? Right. And so after 60,000, you get no gravity. The moon, after 10,000, you get no gravity. You add them both up, that's 70,000. But the moon is 230,000 miles away. You see where I'm going with this? So if we were to take the 60,000 and the moon's 10,000, that's 70. From 230 miles, the 230,000 miles, you've got a difference of 160,000 miles. What does the gravity do then? It doesn't remain dormant. It is a force. You know, it has to do something. It goes away. So therefore, logically, the moon cannot dictate tides on Earth. You know how much force it takes to lift water? Okay? 2 feet. And that's what the tides do. They go up 3 feet. Some places they have tides as big as 10 feet, I heard. I don't know. But say on the average, in Hawaii, I'm just going by the average in Hawaii, 2.7 feet, high tide, and a negative 1.5 feet at low tide. You have the mean or the average, right? This is water level. This is water, I forget what they call it, but there's a point between high tide and low tide when you hit the water level. Okay. So high tide is above that level, low tide is below that level. To move the waters of the ocean that much by pulling on it, if the moon actually does that, then why are our streams, rivers, and lakes still where they are without being affected? Tide doesn't affect streams, rivers, and lakes. They don't have tides. The tides are only affected by the ocean. That means there's a force way down deep that we don't know about that emits from the earth that just pushes the water and recedes the water. Pushes it. It's of a predictable wave. Scientists can predict the tides pretty much. When you're going to get a king tide, when you get a high tide, when you get a low tide, and it's not on a 6-hour basis either. It's on a 5 point something hour. So when you calculate all of that in, you see that the moon is just out there. It's beautiful. Yeah, take it. I love seeing the moon, but it doesn't dictate our tides. It's just a fairy tale. It's just the scientists' fairy tales. Like the moon was made out of cheese. No, it's not. Right. Well, as you get older, you're gonna start questioning a lot of things like that, and people want to know, well, what is this? Where does this force come from? It comes from inside the earth, same place the gravity comes from. There's something. See, we've only gone through 7 miles of earth, of the crust. That's the deepest hole that we've drilled, 7 miles. We've gone deeper with our instruments, but the instruments are mostly seismic. We're only using sound. And we don't know what kind of materials are under. So, how sound, what's happening under the crust. So, they don't really, scientists don't really know what's under there. They don't really know how our planet, acts, what's spinning, which way, how many, and what's causing these cycles. And they are cycles. The tides are cycles. They're predictable. They happen so regularly. They are predictable, day after day after day. That type of perpetual motion is not it's not attainable yet by man. Although man would love to have it. That's I believe there's a prize out there for perpetual motion machine. Yeah, if you can invent a perpetual motion machine, I think you'd get something like $1 million. There is a prize. Man wants to. It goes back to man's arrogance. He wants to control so much, and he believes he can. And certain things, you know, I guess he can control certain things. He is given control of certain things, but you can't control everything. You can't control time. You can't control life and death. Although he'd love to. Man's quest for immortality. You know, man just wants this control, and he explains, gravity, not gravity, but he explains the tide by being, see, I know, it's because of the moon. No, it's not because of the moon, folks. It's just something that the Earth does. Remember, one of the lessons we learned in science was for every action there is a reaction. I know a lot of times we say for every action there is an opposite and equal, but it's not opposite and equal, because in the reaction itself, especially with energy, go to the beach, watch a wave hit a wall, and then you get the wave going back, right? Well, the wave coming in is a lot more violent and stronger than the wave going back. And why is that? Because when it hit the wall, it lost a lot of its energy into the wall. It was absorbed by the wall. And so the wall just gives back out a little bit of the energy. Energy, subsides. And that's what a wave is. A wave is a wave of energy. It's just pushing water. And then it breaks on the shore, and that energy goes into the land. That's all it is, just a cycle of energy. So the gravity soaks in, right? Well, this energy got to be let out somehow. It cannot just keep staying in the earth. The earth has to give it out. Okay? And the earth uses a lot of energy, spinning and everything. Yeah. But then it doesn't use it all, and it gives out some. How does it give it out? One of the ways is by tides. Yeah, it's all about energy, and it's a giant well, it's a giant production of many, many different types of energies. Take, for instance, when a person codes in my unit. Okay, the person codes. How do we bring the person? Why do we even try? Because we found out that it's possible to bring a person back to life. Does it make us gods? No, it doesn't. But yeah. And what happens? I would jump on and give CPR. The nurses bring out the crash cart. They start going up with drugs. RT comes. They start bagging them, giving them oxygen. Okay, so my CPR is putting kinetic energy into that body. We pump in that heart. We forcing the heart to move mechanically. Okay, the nurses will give him drugs. Whatever the drugs that the doctor prescribes, they pump it into the patient. If the patient doesn't have a central line, the first responding doctors will install a central line. But in my unit, usually they have a central line in them already. A central line is just a big IV. It's so big that it has to be placed in a main jugular vein, main femoral vein. It has to be put into a big vein because the sucker is big. It has size. But out of that one IV, there are two, three, or four smaller IVs, but they're still pretty big because some of the um, drugs that we give is very what they call viscous, very thick. So it needs a bigger size IV. You can't use the little ones in your arm, that they put in your arm when you go and you get a drip or something. Yeah, that's just for water and fluids. These fluids are thicker, so they need a bigger IV. And a lot of the chemicals, well, the drugs that we give the patient is more viscous. So a lot of times in our unit, they already have what we call a central line. So they have access to a major blood vessel. So the nurses will just hook up to that blood vessel and just keep and start pumping drugs, whether it be, whatever it is. And a lot of the drugs names, escape me. But you get stuff like epi, and you get stuff like potassium and D5 and stuff like that. But anyway, so the drugs are going in. That's chemical energy. That's what the drugs are. They're chemical energy. Hopefully, the body can metabolize the energy, the stored energy in this chemical into something that's workable for the body. So I'm giving kinetic. The nurses are giving um, chemical. The RTs are giving oxygen, which is another chemical energy, but your body needs the oxygen. It uses the oxygen to create energy to metabolize everything. So yeah, they're bagging them. They have again, a lot of our patients are intubated, so they just take the vent off, attach a ambulation bag that's hooked up to pure oxygen, and they just squeezing, giving breaths. Okay, and the symphony of action to the body sometimes kicks a body start. And like you see in the movie, we shock them, clear, boom, Um, a lot of times we'll do that at the end if we bring the patient back and his heart is fluttering or AFib, right? They shock them to what they do, cardiovert. It shocks the heart to start pumping, rhythmatically again. That's all it does. Um, we I've rarely, seen the paddles and like how in the movies. No, we usually just do CPR because the body, you're not shocking the body. You're just trying to bring it back. So what you're doing is starting the body on a rhythmic pattern that it imitates it's living, and the body will pick it up and on its own it'll catch. The only time we put them on like a defib, like not a defib, but yeah, an artificial defibrillator is when we're going to, and this is really gross, but we're going to harvest something from the body. The body is a donor, and we're keeping it alive with actually we're turning the body into a refrigerator, and we're keeping the organs fresh. I know it sounds really gross, but that's what happens. And until they can get the team together to harvest. Yeah, but it does good because it gives the recipient of the organ a better chance because a fresh organ is you can't beat it. You can't beat a fresh organ. I have a cadaver in my knee, and yeah, I don't know. I don't want a fresh one either, but that's all right. But getting back to my original gravity thing, a lot of times science they make up a story. Okay, that's the only way I've got to explain it. when you see the astrophysicists and their boards and boards of formulations and everything, very impressive, yeah. No, all you've seen is their language. That's their language. It's like if I were to get the recipe for my mom's chocolate cake and write it in Sanskrit, that writing you would not be able to read. And I could read Sanskrit. I'd read it, look at it, read it, and say, okay, this is the um, recipe for chocolate cake. Okay, I oversimplify it, but that's what a lot of times that's what astrophysics do with their formulas. Their formulas is just their language. You watch a person when he comes into like if you looked at Big Bang Theory, and I watch a lot, and you watch Sheldon or Amy when they were working on what string theory, and they wrote it out. They wrote it out. Leonard comes in, and he's looking at it. He's not computing. He's reading it. That's their language. And so he's looking at the formulation, well, the formulas, but it's we call it formulas. That's their language. They know exactly what it says. And if the reasoning comes out correctly, if it makes sense, then they go with it, and if not, they don't. And I don't understand their language. That's why it's so that's why they love it, because it gives them control. You see, without the control, astrophysicists, you know, they call them theories. This is theory physics. There is actual implication. I mean, you can actually do things with some of the stuff that they've come up with. But a lot of this stuff is all theoretical. And theoretical is just a fancy word for make believe. It's their story, their fantasy, their fairy tale. I know it sounds really bad. And it sounds like I'm putting them down. And I'm not putting them down. I'm just trying to make it real. Even what's his name? Tyson, DeGrasse Tyson. Even he said, I'm not a great physicist, and he isn't. He just had media. But if you go and try and debate with them, they will start using terms way up here that we don't use. That's one thing I told you. That's what I've told you in other telecasts or in other videos. They love their own language because it gives them the power. When you start talking to a doctor and he starts going, you know, into his, Latin-based vocabulary, I tell him, whoa, 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 doc, come back to earth, come back to earth. You gotta talk ABC. Right now you're talking up here, and I don't understand it. And they laugh, and they come back. And a lot of times they gotta think because they're so used to speaking in this vernacular, in this vocabulary, that they forget that the little man like me, way down here. But I understand some of the processes of a human body. Therefore, I try to keep it real for me because if I can understand it, I can execute it. Especially for my wife. If we're doing stuff for her, okay, I kind of understand what the process of she does dialysis, peritoneal dialysis. I understand what the process is. I understand, in theory, how the dialysate, which is the solution that we put in her, how the dialysate works, what it uses, why the concentrations of the diuresis or the dextrose, what it does, how to pull it out, what I kind of understand what that is. I had to learn it, and because of my background in health, I kind of understand it. And I fight. I believe in balance. You guys know that. I believe in balance. You get your body to its balance point. And that's the hard part. You gotta know your own balance point. You gotta know where your body is balanced, and it tells you all the time. You just don't. You have to understand it and strive for it. My wife, it's been over a year, and we're finally getting the numbers back to back to where they are, and the doctor doesn't understand. Well, what's happening? Her numbers are great. What are what are you doing right? And I said, her body just had to come back. We took it off. We went on a wild goose chase, and we upset the balance of the body. Her body is coming back. It just takes time. So right now the body's coming back. No news is good news. Let's leave it alone. Let's not mess with it. Because I mean the body is deteriorating. Okay, and every time it deteriorates, it'll give you a sign. And we can't help that. That's just part of life, and that's death. And she ain't no spring chicken anymore. I'm no spring chicken. We all going the other way. So we adjust, and it's you have to adjust for everything. Don't you? A rock is not going to make it in water. It's going to be wiped away by water. Same thing. Just flow with the go with the flow. And gravity is just one of those things. Except yeah, okay, it's powerful. It's there. Gravity is there, but it doesn't do everything that the scientists say it does. It's what I call a DC current. It's a direct current. It only pulls. That's why the sun's gravity doesn't hold the Earth's in orbit, because gravity is not a tractor beam. It's just a pulling thing. In fact, I am not even certain that the sun has a heavy gravity. It has just enough to hold its elements together. But the sun is a giver. It radiates. We are the takers. We suck it in. You catch what I mean? The planets take, the sun gives. That's the balance again. That's how I see it. But that'll be another talk. Okay? But just think about it. But think about gravity. Gravity is just a puller. And things like the tides are just affected by the earth. There's something in the earth, and we don't know yet. We gotta go look at it. But there's no money in it. No, really, there's no money in knowing why we have tides. Just accept, okay, yeah, it's the moon. Easier because, like I said, there's no money in it. If there was money in it, they would have deep sea machines, and they would be figuring out new sonic areas, and all kinds of things they'd be inventing. But there's no money in it. But anyway, that's my spiel for today with gravity. And also, I'm also testing this new mic. Well, it's not a new mic. It's my go-to mic for the outside. It's a mini condenser mic, one of those little mini shotgun mics that go on top of the screen and go on top of the camera. Yeah, you use it for outdoor stuff, but I'm gonna see how it picks up, because this is a controlled audio area. It's not a good controlled audio area. It's not a sound stage, but I try to keep the noise down, and it's maybe 9 to 10 inches away from me, and I've got my audio section down. I've got a switch now. I can switch one of three mics, whichever mic I want. I just turn the knob to that one, and I turn a couple of knobs to adjust the sign, to fine tune the sign, and I've got it. And this is what you're listening to. So anyway, tell your friends about me, and try to start a discussion. See what happens. I know people don't want to talk about gravity, but hey, you wouldn't be here if it wasn't for it. We'd be all floating away, right? Right. Okay. So gravity means something. It's just we're not cued into it. Anyway, please please subscribe, please tell your friends, ask them about it, tell them to watch it, and please leave comments. And you guys have a great week. A couple of weeks, Valentine's Day and Kungi Fachoy, Chinese New Year's. I don't know what it's going to be. Year of the water horse, right? Yeah, but Anyway, you have a good one. Hui ho, ma lama pono. And always from me to you, aloha. See you later. Take care. I love you. Have a good one. Bye bye.